Hello, welcome to all. Um, Previously, we studied that energy band diagram. Uh, for this presentation, the continuation of the previous one, today we learn about the energy band diagram of semiconductor. For this presentation, we are going to learn about the semiconductor. Semiconductors, we know that germanium and silicon material is a semiconducting material. Semiconductors are those substances whose electrically conductivity lies in between conductor and insulator. In terms of energy band, the valence band is almost filled and conduction band is almost empty. Further, the energy band gap between the valence and conduction band is very small. We presented here also is the energy level and the conduction band and is the valence band. In between the valence band and conduction band, a small energy gap is there. This is called as a band gap or energy gap. Therefore, comparatively smaller electric field is required to push the electron from the valence band to conduction band. Simply we have to telling for that semiconductor has almost full valence band and almost empty in the conduction band. A small energy gap is there. The gap value is approximately 1 electron volt between the valence band and conduction band. The semiconductor at a very low temperature, the valence band is completely full and conduction band is completely empty. So therefore, a semiconductor virtually behaves as an insulator at low temperature. However, even at a low temperature, some electrons cross over the conduction band. That means imparting the electrical conductivity to the semiconductor. As the temperature is increased more, a valence electron cross over the conduction band and the conductivity is increases. The figure shows that the electrical conductivity of a semiconductor increases with the rise in temperature. That is, semiconductor has a negative temperature coefficient of resistance. Here, again I explain further insulator. Insulator, it is a material, is a glass material or a diamond material or a silicon dioxide material. It is an insulating material. It's a material with a large energy gap. That means several electron volt. The electron volt is approximately what is that is a 1.6 into 10 power minus 19 joules. In the insulating material, the band gap is very large. Due to the large band gap energy, an electron from valence band to conduction band it cannot easily move because of it's having a large energy gap. I will give a small example for that. For a diamond material, is a carbon material. Energy gap of diamond is approximately 6 electron volt. In the insulating material, the conduction band is almost empty. In valence band, the electrons are there. The electrons cannot move from valence band to conduction band. If you are giving some external giving electric field to the insulating material, the electron cannot pass through the valence band to conduction band. Because of that, it needs more energy because the band gap energy is very high. It means the band gap value is very high, and also the gap value is very high means it cannot easily move from valence band to conduction band. The electrons cannot move from valence band to conduction band. That is the main reason. Okay, insulators does not conduct the electricity. Next one, conductors. I'll give some more important points about the conductors. This type of material having a zero energy gap because the materials in which the conduction and valence band both are overlapped. Here, the valence electron can easily move to valence band to conduction band without requiring the thermal energy. Because the two bands, the valence band and conduction band, both are overlapped. That means the electron easily flow from valence band to conduction band. Hence, a small amount of voltage is required to conduct the electricity. That means the electron easily can flow from valence band to conduction band. So that's why all the metals are having a good conductors. A best conductor material example, the silver and copper material. Semiconducting material. We already, I told already, I explained everything to you for semiconducting material. The material in which the conduction and valence band are separated by a small amount of energy gap. I told that approximately 1 electron volt. It is called as a semiconductor. The pure semiconducting material, silicon and germanium. Most commonly we are using for silicon and germanium material. Normally we are using for that. A small energy gap means that a small amount of energy is required. That is a small energy gap. The small amount of energy is required to freely flow the electron from valence band to conduction band. So the electron moving easily. If it is required a small energy gap, some amount of external energy is required. That means the electrons are flow from valence band to conduction band. A semiconductor behave like as an insulator. It's a very interesting topic. A semiconductor behave like as an insulator at 0 Kelvin because no electrons are available in the conduction band. At low temperature, that means 0 Kelvin, there is no electrons are available in the conduction band. That means this act like as an insulator. If the temperature is further increased, more valence electron will acquire the energy in the valence band to jump into the conduction band. When the temperature increases, the electrons are freely moved from valence band to conduction band. So that we call as semiconductor. If a valence receives sufficient thermal energy, it can move into the conduction band, leaving a vacancy in a valence band, which are called holes. And therefore, if one electron sufficiently thermally energized, it creates a pair of free electron and hole. This process is called as carrier generation. In this valence band, the electron is moved from valence band to conduction band, then one vacant is produced in the valence band. That means, what is that? Electrons move from valence band to conduction means one space is there, and that space is called as the hole. So it creates, that is what is that? Therefore, it is one sufficiently thermally energized. It creates a pair of electron and hole. This process is called as the carrier generation. That means electron and hole are generated. So this is called as the carrier generation. In carrier generation happen due to thermal excitation, photoexcitation, electrical excitation, impact ionization. So these are the methods or happen for carrier generation. When external electric field is applied, the free electron travel within conduction band, producing a current. When the external field is applied to the material, semiconducting material, the electrons travel in conduction band, producing electric current. So that whereas hole travel in valence, it's producing the hole current. So totally, the total current will be the sum of free and hole current. So simply we have to tell for that current total is equal to free electron current plus hole current. So it is equalized. As the temperature increases, the free electron and holes will increase and conductivity will be increased. That is the main reason. See, in the semiconductor, there are two band gap are there. There is a direct band gap semiconductor. Another one is that indirect band gap semiconductor. The process of free electron returning from the conduction band to valence band, which causes the disappearance of a free electron hole pair, is called carrier recombination. In semiconductor, there are two types based on the method of recombination. Number one, the direct band gap semiconductor, indirect band gap semiconductor. Direct band gap semiconductor. For this semiconductor, conduction band in the conduction band is minima and valence band is maxima occur at the same value of momentum. An electron from conduction band directly return to the valence band without changing its momentum and release the energy in the form of light. That is called as a photon. So that is called as a direct band gap semiconductor. See here, this is a conduction band and the valence band. Here, the electrons is come from conduction band to valence band. It can emit the light that is called as a photon. So this is called as a direct recombination. Example, gallium arsenide phosphate. Indirect band gap semiconductor. The conduction band is minima and valence band is maxima. It occurs at different values of momentum. When electron from the conduction band returns valence band after changing its momentum is called as the indirect band gap semiconductor. The energy value changes its momentum by releasing the photon, which is a heat particle. The example is silicon and germanium. See here, this is a conduction band and this is a valence band. The electrons are come from conduction band to in between that is called as the Fermi energy level value. And here what is that? The electrons is come from valence band, conduction band to valence band. What is that? It can emit the light. So it is called as the indirect band gap semiconductor. So here what is that? A hot carrier indirect recombination. In this indirect band gap edge recombination, so it can emit the photon energy, that is E equal to h nu. For this type of semiconductor, there are two types of semiconductors are there. We will study in the next chapter. First one is intrinsic semiconductor. It is a pure form of semiconductor. The periodic table is presented in the fourth group. There is carbon, silicon, germanium, tin, and lead. In its semiconductor crystal, each atom forms 4 covalent bonds. That means this crystal structure becomes stable because the outermost orbit there are 4 valence electrons are there. There is 4 covalent bonds are there. It make a bonding called covalent bonding. That means it is a very stable element. At 0 Kelvin, all valence electrons participate in a covalent bond formation. Conduction not possible. If the temperature is increases, the greater number of electron hole pair will be created. That means it causes the conduction. This is a pure silicon crystal structure. N-type semiconductor is the fifth group of element, phosphor, arsenic, and antimony. So P form the 4 covalent bonds with the silicon and donate with the 5th electron to the crystal. It is called as the free electron. This is a N-type silicon material. The phosphorus atoms create an extra electron. This is a N-type semiconductor material. And P-type semiconductor material is a third group of element, boron nucleus, aluminum, gallium,